Good morning. In this video, I am going to discuss about Friedel-Crafts alkylation reaction and its mechanism. Okay, right. So first of all, let us see what is Friedel-Crafts alkylation. It's a chemical reaction in which a benzene reacts with an alkyl halide. So it's a reaction between benzene and alkyl halide. Alkyl halides such as methyl, ethyl, propyl halides. Okay, right. In presence of anhydrous aluminum chloride, in presence of anhydrous aluminum chloride to form alkyl benzene. Okay, so this is what we call it as Friedel-Crafts alkylation. Benzene reacting with alkyl halide, benzene reacting with alkyl halide in presence of anhydrous AlCl3 aluminum trichloride forming a product which is nothing but alkyl benzene. Okay, right. Now this is an example for Friedel-Crafts alkylation. So I have taken benzene, it's nothing but benzene, isn't it? Right. So with this, I'm going to add an alkyl halide of formula CS3Cl. CS3Cl, which is nothing but methyl chloride or chloromethane in presence of anhydrous aluminum chloride. A Lewis acid. AlCl3 is a Lewis acid, electron deficient species, you know very well. Right. So giving, now what is happening is this alkyl group is getting introduced in benzene ring. And this H and Cl will combine and goes out as HCl. That's why. So now the methyl group is getting added to benzene ring so that you are getting methyl benzene. What is it? Methyl benzene. Yeah, benzene ring which carries methyl group. What you call as methyl benzene, which has another name toluene also. Okay, and byproduct hydrogen chloride. Okay, this is a net reaction. Okay, with benzene, when methyl chloride added, you are getting methyl benzene and hydrogen chloride. Okay, now let us see the mechanism of this Friedel-Crafts alkylation reaction. Okay, right. Actually here the first step is nothing but formation of an electrophile. Actually this Friedel-Crafts alkylation reaction is an example for electrophilic substitution reaction of benzene. What is it? Electrophilic substitution reaction of benzene. So that what is happening is in benzene the H plus electrophile is getting substituted by alkyl electrophile. That's why it's called as Friedel-Crafts alkylation. That's why it's called Friedel-Crafts electrophilic substitution reaction also. Okay, right. Friedel-Crafts alkylation and electrophilic substitution reaction. Okay, so that very first step of this mechanism, we are supposed to form an electrophile, isn't it? Right. Now this is the electrophile formation step. That alkyl halide, that is methyl chloride. What is this one? CS3Cl is nothing but methyl chloride, isn't it? Now methyl chloride reacts with the Lewis acid AlCl3 aluminum trichloride. So this Lewis acid is in need of electron. So now what will happen is this Cl will come over here. That Cl of alkyl chloride, methyl chloride will come over to AlCl3 with a bond pair as Cl minus, and it is getting added with AlCl3. So it forms AlCl4 minus. But now when this bond pair comes over here, that CS3 group is losing electron, isn't it? So that CS3 carbon will get a plus charge. CS3 carbon will get plus charge, which is nothing but an electrophile. A positive species is what we call it as electrophile, isn't it? Okay. Right. Now this is the first step of the reaction mechanism, electrophile formation. Okay. Right. Now the electrophile attacks the benzene ring because you know the benzene ring is electron rich species, isn't it? Because in benzene there are 3 delocalized pi bonds inside the ring structure, so that's why it is acting as a electron rich species, so that methyl electrophile, CS3 electrophile, can readily approach benzene ring so that it can get electron from benzene ring. Okay, now when CS3 plus group approaches benzene, so what will happen is this pi electron, what is this? This pi electron will be shared with that methyl group, so that methyl group is getting attached with this carbon, isn't it? And already there is a hydrogen. Present in this carbon. Okay, right. Now when CS3 group gets attached over here, the adjacent carbon, this carbon, is losing its electron, so it gets a plus charge. It becomes a deficient center. Okay, right. C plus center is nothing but C plus. What do you call it as? Arenium ion. What is the name of this species? A benzene ring in which there is a positive charge over carbon atom of benzene ring, what is called as Arenium ion, because Benzene has another name arene. So benzene carbon with a positive charge is called as Arenium ion. Okay, right. So this is a second step actually. You can have this as a second step, formation of Arenium ion. This you can consider as formation of Arenium ion. Okay, right. Right. Next, third step, removal of H plus ion from this Arenium ion. So this I have written again here. Now that AlCl4 minus, what we have got in the first step, AlCl4 minus, which is formed in the electrophile formation step, comes over here and it removes this hydrogen. Removes this hydrogen as a proton. Okay, right. Now by the time what will happen is this this pair of electron will move inside the benzene ring so that it becomes a normal benzene ring. Okay, you got it? Right. And that H plus which comes out will combine with AlCl4, becomes as HCl and AlCl3. That AlCl4 minus will give out one Cl minus, so that H plus and Cl minus combines giving HCl, so that AlCl3 will be regenerated. Okay. And now you are getting a product which carries product benzene, which carries a methyl group, which is nothing but alkyl benzene, what we call it as toluene. Okay, right. So this is what the mechanism of Friedel-Crafts alkylation reaction. Okay, I think you are able to follow the reaction. I think so. Okay, first step, this is the first step, electrophile formation. What I said, the second step is nothing but formation of Arenium ion. Third step is nothing but deprotonation. Third step is nothing but what? Formation of product or deprotonation, removal of proton H plus from Arenium ion, isn't it? So that you can take this as a deprotonation step. Okay, right. Like Friedel-Crafts alkylation, we have two more Friedel-Crafts reaction which are called as Friedel-Crafts acetylation. Another one is nothing but Friedel-Crafts benzoylation reaction. Okay, they are similar to Friedel-Crafts alkylation. Only thing, the electrophile formed are different. Okay, right. Now so I have written Friedel-Crafts acetylation reaction. Benzene, this is benzene. When benzene reacts with CH3COCl, an acid halide which is called as acetyl chloride. Is an acid halide of acetic acid, so it is called acetyl chloride. Okay, benzene with acetyl chloride in presence of the dry AlCl3, anhydrous AlCl3. Now what is happening is this acetyl group, CH3CO group, is getting introduced instead of hydrogen in the benzene rings. As a result of that, you are getting this as a product. Okay, the name of the product is a ketone because it has functional group CO. So ketone, which is called acetophenone, and as usual hydrogen chloride will be the byproduct. Okay, right. Here the mechanism, first step will be as usual, formation of an electrophile. So acetyl electrophile. Now the acetyl chloride, the CH3 COCl is what? Acetyl chloride reacts with the Lewis acid AlCl3 and forming an electrophile of formula CH3CO plus. So what you can call it as acetyl electrophile. Acetyl electrophile. Okay, acetyl ion, right? Okay. Now this acetyl electrophile will approach benzene ring, and ultimately you will get first you will get a Arenium ion, then that Arenium ion, this is Arenium ion, then that Arenium ion after the removal of H plus, that is after deprotonation, will give ketone of formula benzene ring with COCH3 group, which is called as acetophenone. Okay, so that the product of Friedel-Crafts acetylation is nothing but acetophenone compound. So I have explained the mechanism. I think you can follow that. Okay, similarly the third Friedel-Crafts reaction is nothing but Friedel-Crafts benzoylation reaction. The previous one is acetylation because we take benzene ring and finally we introduce this group, acetyl group. So it's called acetylation. Introducing acetyl group to benzene ring is called acetylation. Similarly, this is Friedel-Crafts benzoylation, which means we take benzene and we introduce a group, CH5CO group, benzoyl group. What is this called? Benzoyl. So by adding benzoyl group to benzene ring is nothing but Friedel-Crafts benzoylation reaction. Okay, this is a net reaction. Benzene reacts with a compound of formula C6H5COCl, which is called as benzoyl chloride. What is this called? Benzoyl chloride. It is a chloride derivative of benzoic acid, so that's called benzoyl chloride, giving a product what we call it as benzophenone. Okay, right. Diphenyl ketone, which can be also called as diphenyl ketone, a keto group with two phenyl group on either side. That's why it's also called diphenyl ketone. Okay. So this net reaction, as usual, the first step, electrophile formation. Okay. Now the benzoyl chloride reacts with AlCl3, aluminum chloride, and forming an electrophile of formula C6H5CO plus, isn't it? Benzoyl electrophile, isn't it? Now that benzoyl electrophile will react with benzene ring. Benzene generates electron to this electrophile, so that C6H5CO group is getting attached with this benzene ring. Okay. And the neighboring carbon gets a plus charge. What you call it as Arenium Ion. What is this product called? Arenium Ion, benzene ring in which carbon carries a plus charge, isn't it? Next step, deprotonation. What is it? Deprotonation, removal of H plus ion. That removal of H plus ion occurs in presence of that AlCl4, what we got in the fourth step, isn't it? Right. Now finally you are getting the product, benzophenone. Actually when this comes out as H plus, this bond move inside, it becomes a normal benzene ring. Okay. Right. I hope you understood about the various Friedel-Crafts reactions as well as the mechanisms. Okay, right. Thank you and keep watching my videos.